A ceramic power resistor is a common type of resistor used in circuits to dissipate large amounts of energy as heat. They are labelled with a power rating and resistance value. Two examples are shown below. Resistor 1 has got a power of 10 watts and resistance of 4 ohms, and resistor 2 that's got a power rating of 10 watts and a resistance of 16 ohms. A. State which of the two resistors will allow the greater current to pass. Now the common rule for this is the greater the resistance, the less the current, and vice versa. The less the resistance and the greater the current. You may have done an experiment in class to show that, and you've got this curve. As the resistance increases, the current decreases. So the answer to the question which resistor will allow the greater current to pass will be resistor 1, because that's got a resistance of 4 ohms, which is less than 16 ohms. 6b. The resistors are connected in the circuit shown, and we've got a 6-volt source connected to two resistors in series, and we have a voltmeter across the 4 ohm resistor, and we are asked to calculate the reading on the voltmeter. Now, to find the reading on the voltmeter, we have to find the voltage across the 4 ohm resistor. Now, to find the voltage across the 4 ohm resistor, we have to apply Ohm's law to the 4 ohm resistor, which means we need to know the current in the 4 ohm resistor and the resistance of the 4 ohm resistor, and that's simply going to be 4 ohms. Now, to find the current in the 4 ohm resistor, we need to find the total current in the circuit, and the total current in the circuit will be the voltage source, 6 volts, divided by the total resistance, and the total resistance here will be 20 ohms. We just add them together. Now, when we get that total resistance and we divide it into the voltage, we get the current in the circuit, and that's the current in both resistors, the 4 ohm resistor and the 16 ohm resistor. Then we multiply the current by the 4 ohms, and we have got the voltage across our 4 ohm resistor, and therefore the voltage reading on the voltmeter. 6 part C. The two resistors are now connected in another circuit as shown. There we have two resistors in parallel now, and we've got an ammeter measuring the total current in the circuit, and we've got the same 6 volt source. And we are asked to calculate the total resistance of the circuit. Those are two resistors in parallel, so we use our resistor in parallel formula. 1 over total resistance is equal to 1 over R1 plus 1 over R2. We can choose either the 4 ohm or a 16 ohm resistor to be R1 or R2, put them in the formula, treat it like normal fractions, reciprocate in the end to get your total resistance, and notice the answer is always less than the value of the lowest resistor, which is 4. Part 2. Another ceramic power resistor is now connected in parallel with the two resistors in the circuit. State the effect this change has on the reading on the ammeter. First of all, notice the position of the ammeter. The ammeter is measuring the total circuit current. Now, if we add another resistor in parallel to those two, the total resistance will become less. And if the total resistance is less, the current will be greater. So the answer to the question is add a resistor on parallel and the current will get greater. So why does the circuit resistance become less when you add a resistor on in parallel? Well, when you add a resistor on in parallel, you're providing another path for the current to travel in. The more paths you offer the current to travel in, the less resistance the circuit has. And you can also verify it using the formula.